HVAC parts of an HVAC system that collectively help an HVAC system work for whatever that may be, heat, air, etc. This particular part here is a contactor. So as the name says, contactor, what it allows the system to do is make contact from here to here. So hence I'm wondering if that's where the name is derived from. So we have on the bottom end, we have 120 volts here, 120 here, plus or minus approximately. This 120 here, 120 here collectively equals 240 volts. 120 plus 120. We have 0 here, 0 here. When the coil comes in and this plunger goes down, if the contactor is good and operating properly, then this 120 becomes 120 here, this 120 becomes 120 here, 120, 120 is 240, plus or minus. Sometimes the voltages vary, but this is just a generalized statement. So this is high voltage, and one should have a working understanding of electricity. Otherwise, you could get in a mess if you're not, because this is electricity. It will shock, so it's not like low voltage. So the contactor here, we got high voltage here, high voltage here, high voltage here, high voltage here, if this is connected in. So what draws this in? This is drawn in by this prong here and this prong here, which is low voltage, which is not very harmful in my opinion, maybe 24 volts. So if the contactor is energized, say if it's calling for cool, and one goes over here to their multimeter, and they say the multimeter has this, so if one turns this on, and let's see here, so it goes to voltage here. Let's go to volts AC. Okay, turn the backlight on, and that will work. Okay, now these volts here, just ignore these. Some of these meters actually run millivolts or something. So when they're doing this is not what you're looking for. So if you took one prong here, you have two prongs. If you take one prong and touch this, and the other side and touch this prong here, you should be reading on this voltmeter. It should read anywhere from around 24 to 27 volts if the contactor is energized. So the contactor has to have a call for, say, whatever that may be, say an air conditioning mode, the thermostat has to call. So if the thermostat doesn't make a call for this, then at this point, there may not be any electricity, because the electricity is not making a connection within the thermostat to send the signal out to the unit. But if it's energized and calling for cold, and one touches this prong and this prong, this meter should read 24 to 27 volts. And again, we set the meter to volts AC to read this. So, and it should read, normally it's 24 volts, but 24 volts, sometimes the meter may say 24, 27. So, and again, but now if the thermostat has not called for it and it's dead like it is now, and there's no electricity, you will get nothing on your meter. Your meter will not read anything. But once you touch the red and the black prongs, one to one side, one to the other side, and if it's called for air conditioning or whatnot, the contactor is energized, meaning the coil, meaning if it's energized, this should pull down. One leg should be the hot, one leg should be the common, and at this point your meter should read about 24 to 27, 28 volts plus or minus. So this is determining if you've got low voltage out at your. Now I'm assuming if one powered it down and took the wires off, you could take the prongs and put in the end of the wires without being attached here. And if you put both leads on the ends of both wires and had a call for, say, air conditioning inside at the thermostat, you should pull 24. Then you know your wire. If you have a problem, you know your problem's on downstream, because you should be pulling the same voltage off of the wires, even if they're not connected, in my opinion. So I'm not saying that's fact or fiction, but this is that sometimes this stuff is just step down diagnosis. You diagnose one thing, then you go downstream, you diagnose another thing, etc. So but this is a contactor for heating and air conditioning, HVAC uses, energized by low voltage, hot in the common, pulls the coil in. Once the coil's in, you've got, this is live with one, if all things are wired up equally, this is live at all times. This is live with 120, hypothetically, plus or minus. Once this is pulled in, this 120 goes to here, this 120 goes to here. You collectively have 240 volts, and that's enough should be enough to run your condenser fan motor and your compressor outside. Thank you for watching. Have a great day.